right, guys, are there any questions over any of the assignments so far? Any questions over 10.1 through 10.3 before we start looking at 10.4? All right, let's put the Chromebooks away and headphones out. Now, what we're talking about today, and the first thing we're going to talk about is an inscribed angle. An inscribed angle is an angle whose vertex is on the circle. So an angle whose vertex is on the circle, like this here, and whose side contains a chord of the circle. An arc that lies between two lines, rays, or segments is called an incepted arc. So this here is the incepted arc of it. Now there's this actual equation that comes from this, an inscribed angle, which is that the measure of the inscribed angle is 1/2 the measure of its arc. So if this is 140 degrees, the measure of this angle is half of it, so half of 140 is 70. Or that the measure of the arc is twice the measure of the inscribed angle. So if we're given the angle here, we can multiply it by 2 to get the measure of the arc. Now if we look at the first example of this here, we're given this example here, this equation. Go back one. Now the first thing we're asked is the measure of angle T, this angle here. Well, the arc that composes it is what measure? 48 degrees. The measure of the inscribed angle is half the measure of its arc. So we would take 48 and multiply it by 1/2 or divide it by 2, and exactly we would get 24. So the measure of angle T here is 24 degrees. So the inscribed angle is half the measure of the arc. Any other questions on part A before we look at part B? Now part B, we're trying to find the measure of arc QT. So if the inscribed angle is equal to half the measure of the arc is equal to twice the measure of the inscribed angle. So if this is 50 degrees, to get to the arc, well, we're going to take 50 and do what? Times it by 2. And 50 times 2 is? So the measure of arc QR is 100 degrees. And that's it. Questions on either one of these here? Let's look at the next one. Find the indicated measures. So we want to find the measure of angle G in the arc DG. So we can find the measure of arc DG first. So arc DG is from here to here. If the inscribed angle is 40, well, we're going to take 40 and what? Multiply it by 2. 40 times 2 is 80. So the measure of arc DG is 80 degrees. Now the other part is to find the measure of angle G. Well, the arc that composes it, inscribed angle, is 58. We divide it by 2 or multiply it by 1/2. Either way, so the measure of angle G, our inscribed angle, is 29 degrees. Because an inscribed angle is equal to half the measure of its arc, and an arc is equal to twice the measure of the inscribed angle. Okay. So find the measure of arc RS, and then we want to find the measure of angle STR. Let's find the measure of RS first. Well, how would we find the measure of arc RS? Right, because 31 is the inscribed angle that composes it. So we would take 31 and multiply it by 2, which would give us, so 62 is the measure of angle of arc RS. Now to find the measure of STR, what are we going to do? We would divide 62 by 2. Now what do we notice about STR and RUS? They're congruent, yes? They have the same measure. Which actually leads us to the next theorem. Yes. Inscribed angles. Two inscribed angles of a circle intercept the same arc. Then the angles are congruent, which is exactly what we saw here. STR and SUR, both of those inscribed angles have the same arc, RS. So they're going to be congruent, which is what this theorem says. Two inscribed angles of a circle intercept the same arc. Here, AB. It means that those two angles have to be congruent. They have to be the same. Questions on this here? Find the measure of angle F. We're told that E is what? So what's the measure of angle F? Because since these make up the same arc or connected to the same arc, these two angles have to be the same. And that's it. Questions on this here? So they told us that the measure of angle C is 68, and we want to find the measure of angle B. Yes. Because since angle C is composed or connected to arc AD, and angle B is also connected to arc AD, it means they both have to be 68 degrees. Any questions on this here? Find the measure of the red arc. So here, we're wanting to find the measure of angle G. What would it be? Yes, because we're taking 90 and dividing it by 2, which would be 45. How about the next one? Well, we're going to take 38 and do what to it? Multiply it by 2, because we're going from an inscribed angle to an arc. And 38 times 2 is 76. And lastly, we want to find the measure of angle X. It would be 72, exactly, yes. Because since these two angles share the same arc, they're going to be congruent to each other. Any other questions on this here so far? Let's look at the next theorem. A polygon is considered to be an inscribed polygon if all the vertices lie on the circle. The circle that contains the vertices is a circumscribed circle. So whenever all the vertices of a polygon lie on the circle, it's called an inscribed polygon. And when the circle that contains all the vertices is a circumscribed circle, kind of going outside. The circle is inside the figure. This here, inscribed and circumscribed polygons. Now, an inscribed right triangle theorem. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of a circle. Conversely, if one side of a triangle is inscribed as the diameter, then that is the right angle. Well, let's look at this here. So this is a triangle inscribed inside of a circle, yes? Now we know that AC is the diameter because it goes through the center, point D. What is the measure in degrees from A to C here? 180. It's half the circle, yes? Now we said an inscribed angle is equal to half the measure of the arc. What's half of 180? So angle B here has to be 90. And that's all this is saying. If a triangle is inscribed in a circle and one side is the diameter, goes to the center, it's going to have to be a right triangle because that angle has to be 90 degrees. Questions on this here? Find the value of each variable. So here. So, yes. Yeah, for some reasons it disappears on this one. Now, this here, AB is the diameter, yes? Which means this arc here has to be 180. Which means the measure of this angle here has to be 90. So here 2x is equal to, what do we need to do to solve for the value of x? Divide both sides by 2. 2x divided by 2 is x. 90 divided by 2 is x is equal to, that's it. Any questions on this here? Yeah. What do we need to do for this one here to find the value of x? Right, because WY is the diameter, which means this has to be a right angle. So 5x is equal to, and then we would divide both sides by 5. And that's it. Any questions on this here? Any questions on how we got the value of x? Or set this up? 18. I don't know how I heard 15. 18. That makes more sense. Any other questions on this here? Let's look at the next one. Well, this one's here is asking for two variables. And we do know that Km is the diameter. So what do we know about the value of x? X has to be 90. This is going to be a right triangle. So what can we do to find y? As we know that the sum of the interior angles of any triangle is 180. So 90 plus 40 is, and we can take 180 and subtract 130, which gives us 50, because the sum of the interior angles of any triangle is 180 degrees. We found x, which is 90. So y plus 90 plus 40 should give us 180, which tells us y has to be 50. That's it. Any other questions on any of these here? And the last main theorem that we're going to look at, the last theorem we're looking at today is this one here, the inscribed quadrilateral theorem. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. If the opposite angles are supplementary, they add together to be 180. Well, And it makes sense because here angle E is equal to half the measure of arc DG. So it's equal to half the measure of this arc, yes? Now, angle G equal to half the measure of DEF, yes? But the green arc and the black arc add together to be what? The whole circle, doesn't it?
Oh, 360.
360. But we're saying that the inscribed angle is half the measure of its arc. Well, if we add these two together for the inscribed angles, well, their arcs add together to be the whole circle. Half of 360 is 180. And that's why this works. So, y and 120 should add together to be what? 180. So y plus 120 is equal to 180. What can we do to find y? We can subtract 120 from both sides, which tells us y is 60. Yes, because z plus 80 is 180. Minus 80 from both sides. Z is equal to 100. And that's it. Any questions on any of this here? Are we ready for the next one? Do we want to solve for A or B first? A. So what do we know about 3A and 111? So they add together to be 180. What can we do first? We can subtract 111 from both sides. These will simplify to 0, telling us that 3A is equal to 69. And then we would and A should be 23. Yeah, so B is going to be B plus 65 is equal to 180. And at this point here, we can subtract 65 from both sides, telling us B is equal to and that's it. Any questions on any of this here? Any questions on anything we've done so far? Do we need to see? Let's look at this one here. This will be the last one we look at. Now this time, both sets of angles have variables in it. But that really doesn't change what we're doing. Because again, C and 2C minus 6 add together to be what? What do these two angles add together to be? 180. Now at this point, we can combine like terms. So C plus 2C is 6 is equal to. Then what can we do next? Add 6 to both sides, because negative 6 plus 6 is 0, leaving us with 3C is equal to 186. And then we would divide both sides by 3. 3C divided by 3 is C, and 186 divided by 3 is, so the value of C is 62. How about with x? We'd have 10x what? Plus 8x is equal to 180. Yes, because we can add those two together. 8 and 10 would be 18, and then divide both sides by. That's it. Any questions on any of this here? And that's it.